Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss the orbital overlap concepts of valence bond theory. Class number is 080. During the formation of hydrogen molecule from two numbers of hydrogen atoms, it will take minimum energy to come close to each other, and their orbitals will penetrate to each other to get a covalent bond. And this merging of atomic orbitals, it is called overlapping of atomic orbitals. And it results the pairing of the electrons. This is the pairing of the electrons. This extent of overlap, it decides how strong this covalence. Greater the extent of overlap, that means stronger the bond formed. And during this formation of bonds, this pairing of electrons of the valence shell, which means these electrons are in opposite spin. Now we consider about the polyatomic molecules: methane, ammonia, and water. Three examples and their geometry in addition to the bond formation. Example: why the methane molecule has bond angle 109.5 degree, and why the shape of the ammonia molecule is pyramidal. The valence bond theory explains the shape, the formation and directional properties of bonds in polyatomic molecules, these molecules, in terms of overlap and hybridization of atomic orbitals. And in right side figure, you have seen that two atoms come close together to form bonds, and their overlap may be positive, negative, or maybe zero overlap. Whether it is positive or negative or zero overlap, it will be decided by this direction of orientations of amplitude of orbitals. This is positive and negative sign. This is a positive sign and this is the negative sign. This is related to the boundary surface, and it is a wave function. The sign is related to wave function, and this positive and negative, it is not the charge. We have to remember this. And when the positive, this positive will penetrate this orbital with another positive, then it is called positive overlap. And similarly, when one positive part penetrate with the negative part of the orbitals, then it is called negative or out of phase overlap. And when two different types of orbitals penetrate to each other, in this case the p orbitals penetrate with the s orbitals, in this case zero overlap, or it may be called out of phase due to different orientation, direction of approach. The criteria of overlap as the main factor for the formation of covalent bonds applies uniformly to the homonuclear, heteronuclear, diatomic molecules and polyatomic molecules. We know from experiment that methane molecule has tetrahedral structure, shape. Ammonia molecule has pyramidal in shape, and H2O molecules bent in shape. So it would be therefore interesting to use the valence bond theory to find out if there is geometrical shapes can be explained in terms of orbital overlaps. We'll see now. This is the methane molecule. This is the methane molecule, and this methane molecule is formed by 1 number of carbon atoms and 4 number of hydrogen atoms. Carbon in its ground state, outer atomic orbitals, electronic configuration 2s2 2p2, and when it will be excited, then outer shell orbitals, electron configuration 2s1 2px1 2py1 2pz1. That means before formation of molecules, each atom should have unpaired electron. And whatever the energy required for this excited state, this will be compensated by the formation of these bonds. That means whatever the energy released due to the formation of bonds, this will compensate the energy required to get the excited state of the carbon atom. Then the 4 atomic orbitals of carbon, each with an unpaired electrons, can overlap with 1 s orbitals of the 1, 2, 3, 4 hydrogen atoms. This will result in the formation of 4 CH bonds. This excited state is later modified with the concept of hybridization that we'll understand in the next class. Because according to this concept, that means this valence bond theory is that orbital overlapping concept, the 3p orbitals of carbon are at 90 degrees to one another. So the hydrogen carbon hydrogen atom angle for these 3 bonds are also be 90 degrees, but in practically it is not like that. The 3 CH bonds will be oriented at 90 degrees to one another, and another 2s orbitals of the carbon, which has also single electron, it should bond with the 1s orbitals of the hydrogen atom. Both are spherically symmetrical because these are the s orbitals, so they can overlap in any direction. So the direction of the 4th CH bond cannot be ascertained. So this is the limitation of overlap concept. This overlap concept does not fit with the tetrahedral HCH angle of 109.5 degree case of methane. And clearly it follows that this atomic orbital overlap, what I discussed now, it does not account for the directional characteristics of bonds in methane. We use a similar concept, atomic orbital overlap, this concept. Then it can be seen that for the hydrogen, oxygen, hydrogen, this angle in H2O molecules should be 90 degrees. But this is also disagreement with the actual bond angles of the NH3, which actual angle is 107 degrees, and for the H2O molecules, whose HOH angle is 104.5 degrees. But as per this atomic orbitals overlap, both should be 90 degree angle. But practically it is not like that, and this is the limitation of this overlap concept. I hope that you understand this overlap concept and what is its limitations also. I have the podcast in the same name, Dr. Acharya Academy, for honors degree high level chemistry education. You can go through this to get more knowledge about the chemistry. Thank you so much for watching this class.